Okay, we're starting chapter 4. And chapter 4 is called Congruent Triangles. The first section, 4:1, is actually called Congruent Figures. So even though the chapter is congruent triangles, we're going to start with any figures, circles, polygons. I mean, in reality, we're just going to look at polygons. For those of you that have your books and you want to read along with me on page 198. So the definition of congruent tells us that congruent figures have two things that are the same. Anybody remember what that is, Anthony?
Angle.
If they have angles, yeah.
Same size.
Same size. Who said that? Same size and same shape. Thank you. Thank you, Peter. So if you have two figures and they are congruent, that means you can move one of them so that it fits exactly on top of the other. So again, if you're looking at page 198, you'll see some teal color shapes, and it talks about sliding one so that it's on top of the other, turning one and moving it on top, and flipping so that it's on top. So if you slide one image onto the other and the vertices match and the sides all match, then that figure is said to be congruent. Now, sliding, turning, and flipping are ways that we translate or transform figures, and we're going to look at those in chapter 9. And in chapter 9 we'll probably do our tessellation project, because tessellations have a lot to do with transforming shapes. Okay, are we finished with these notes?
If you have a first period, why don't you record then?
Because I've now had 2 times to go through it.
Oh.
When the vertices and sides match, we call these corresponding parts. Very important term. We're going to be using this a lot. So let's draw 2 triangles. And you all know my drawing skills are really bad. So I am telling you, even though it doesn't look like it, that triangle ABC is congruent to triangle DFE. So if I were to take the triangle on the left, DFE, and I were to actually like cut it out rotate it and slide it on top of triangle ABC, you would see that vertex D goes directly on A, F goes on B, and E goes on C. Okay, so I rotated it and slid it over and dropped it on top.
What about the flip?
So matches to B, A matches to D, B matches to F, and C matches to E. So, what are the corresponding parts? There are 6 sets of corresponding parts. Let's see if we can figure them out. Let's start with the angles. So angle A is congruent and corresponding to what angle? Anybody? A is congruent to angle D. Angle B is congruent to angle F. And angle C is congruent to angle E. Very good. So those are the angles. What do you think the other 3 parts are going to be? You did
Length of lines.
the sides. So AB,
DF.
very good, is congruent and corresponds to DF. VC is congruent and corresponds to BC, FE. And CA, ED. Very good. Now, sometimes you can look at the 2 figures and find the answer. Sometimes you'll have to look at the way it's written. It's a little bit easier. It follows a pattern: AB, DF, BC, FE, CA, ED. Okay, so I want you now to find all of the corresponding parts if triangle WYS is congruent to triangle MKV. Okay, and I'm not going to draw the picture, you're just going to use this statement. I'll start one for you. Angle W is corresponding and congruent to M. Okay, why don't you take a minute and find the rest of them.